Subtopic 1.2 Collision Theory. The first objective, explain collision theory. Collision theory is the theory that proposes to explain the rate of chemical reaction. The basic of collision theory are molecule of reactant must collide in order to form product. So, for example, 2 mole AB produce 1 mole A2 and 1 mole B2. So the two molecules AB must collide in order to form the product. And the second idea is products are formed only when effective collision occurs between the molecule. The effective collision only occurs when these two conditions are fulfilled. First, the colliding molecule must have a total kinetic energy equal to or greater than the activation energy. And the second condition is collision occur at the correct orientation. Second objective, define activation energy. Activation energy is defined as the minimum energy required to initiate a chemical reaction. The activation energy may be gained through the collision between the molecules. This energy is used to break the bond and to form a new bond between the reactant molecule. The next objective is explain transition state theory. Transition state theory is the theory that used to explain in detail what happened during the collision. The best way to explain the transition state theory is by using the energy profile diagram. Energy profile diagram is a diagram that shows the relationship between potential energy and activation energy. Let's use the same example. 2 mole AB produce 1 mole A2 and 1 mole B2. In order to form the product, reactant molecule must collide. During the collision, kinetic energy converted to potential energy. That is potential energy of the reactant molecule. The height of potential energy barrier is called activation energy. Activation energy is the energy required by reactant molecule to form the activated complex. So, if the colliding molecule possess energy equal or greater than EA, so it can be converted to product. But if the colliding molecule cannot possess activation energy, so the colliding molecule will be converted to reactant. So activated complex is a temporary species formed by the reactant molecule as a result of the collision. So activated complex or transition state. At this state, the bonding between reactant molecule start to break and the product bond start to form. So activated complex form the product. The last objective is draw energy profile diagram of a reaction. There are two types of energy profile diagram. The first one for exothermic reaction and the second one for endothermic reaction. Let's consider the general equation given. A react with B, produce C and D. Let's say this reaction is exothermic reaction. So how to draw energy profile diagram for exothermic reaction? First, you need to draw y-axis and label as potential energy. Next, draw the x-axis and label as reaction progress. Next, you need to draw the line as shown on the slide. So for exothermic reaction, the potential energy of the product is lower than reactant. Next, label the reactant at the beginning of the line and label the product at the end of the line. So you need to label reactant and product same as in the balance equation. Okay, next, the potential difference between barrier and reactant labeled as EA, activation energy, and the difference between reactant and product labeled as delta H, enthalpy change. So for exothermic reaction, delta H has negative value. So if the question gives the value for delta H, so you need to write the value of delta H on this energy profile diagram. Let's say the reaction is endothermic reaction. So how to draw energy profile diagram for endothermic reaction? Same concept. So first draw y-axis and label as potential energy. X-axis and label as reaction progress. Draw the line as shown on this slide. So for endothermic reaction, potential energy of the product is higher than reactant. Next, label the reactant at the beginning of the line and product at the end of the line. So you need to label reactant and product same as in the balance equation. Next, the potential energy difference between barrier and reactant labeled as activation energy EA, and the difference between potential energy of product and reactant labeled as enthalpy change delta H. So for endothermic reaction, delta H has positive value. So if the question give specific value, so you need to write specific value of delta H on energy profile diagram.